So logarithms. Logarithms are powers. So if we look at this, okay, 10 to the x equals 3, for example. The power is x. Logarithms are powers. And so if I want to find out what number I've got to raise 10 to, what power I've got to raise 10 to get 3, I find the logarithm. So the logarithm to the base 10 of 3 is the power to which I have to raise 10 to get 3, is what we call the logarithm of 3. And there's a button on your calculator that allows you to find that out. And it's got log written on it. So if you hit log 3, you get a number, which is 0.477121. 6 significant figures. Okay? What that's saying is that 10 to the power 0.477121 is 3. So therefore, 10 to the power 0.477121 should be 3. And it's no coincidence that the 10 to the power button is above the log button on your calculator, because they're inverse to each other, inverse functions. So shift log button will give you 10 to the power 0.477121, and you should just about get 3. Near enough. Well, you need to put in the power. This is another point coming out here. We hold on to quite a few significant figures when we use logarithms, because their powers, a small change in this power makes a big difference to the final answer, because it's 10 to that power, Daniel. So 10 to the power 0.5 will be nowhere near 3. So you need to hold on to the 0.477, at least 4 significant figures generally. Come to that, Chris. That's the natural log button. Okay, so logarithms are powers. 10 to the power 0.477121 is 3. So if I wanted to solve this, if I want to find x, I'd have to find the logarithm. So 10 to the power x equals 5.8. How do I solve it to find what x is? Find the logarithm, right. To find x is the logarithm to the base 10 of 5.8, which is so in other words, 10 to the power 0.76342 will give us 5.8. That's what logarithms are. Logarithms are powers. Now, logarithms can be very useful to explore power functions, as we'll see. Because logarithms are to do with powers, when we come on to power functions where the variable is in the power, for example, then we need to use logarithms. They're also useful in other ways. We can come up with some laws of logarithms which come from the laws of indices. For example, let's look at a situation where 3 times 4 is 12, okay? Now, if I turn this 3, and this is the use of logarithms, I can turn 3 into a power of 10. What would x be if I want to represent 3 as a power of 10? How would I find out what x was? Right, we just worked it out, didn't we? Because that's a logarithm of 3. So 0.477121. 0.477121 times by, what would 4 be in terms of 10 to the power something? What would I have to do? Log 4. What is that then, please? Sorry, Chris, say again. 0.602. Right. Now, in theory, if I work out what that is, I should get 12. Okay? But from the laws of indices, same base 10, what do I do with the powers? Yeah, what would I do? Of course, Daniel, but I'm trying to make a point here. What do I do with the powers of the laws of indices? Add them together. What's 0.477121 plus 0.602056? It's going to be 1 point something, isn't it? 07. Right. Now, if I work out what 10 to the power 1.0791 is, should be 12 if this has worked, which is the point I'm trying to make, Daniel, okay? In other words, and this is something that I used to use before calculators came along, if I wanted to work out what two numbers were, multiply two numbers together, obviously not 3 times 4, but some quite long numbers, what you would do is you turn them into logarithms. You'd find the power to which 10 has to be raised to get that number. So I'd look up in a table of logarithms for what the logarithm of 3 was. I'd look up what the logarithm of 4 was in a table, add them together, and then work out what 10 to the power that was, again by looking at a table to get the answer. Okay? And what it's using is the fact if I multiply numbers together, and this is the point I'm trying to make, I turn them into powers. If I turn those numbers I multiply together into powers, I add the powers. And that gives us the first law of logarithms. If I multiply two numbers together, if I log them, I end up adding the powers. So the logarithm of two numbers multiplied together is the log of the first plus the log of the second. That's the first law of indices. Similarly, and we won't bother to do this, you can show that the log of a number divided by another number is the same as the log of the first minus the log of the bottom number, the denominator. And the most important one is here. Looking at this, the third law of logarithms, as it's often referred to, if I've got log a, which remember the logarithm of a is a power, raised to another power, if we think back to the law of indices, when I had one power raised to another power, I in fact ended up multiplying. And that's what's going on here. I bring the power down, the n, and multiply it by the log of a. So those are the laws of indices. If you want to make a note of them, it might be worth making a note of them together with the laws of indices because they go together.